Hi, in this video, I'm going to show how you can solve any conditional probability problem by creating a table. This even works for really hard problems like Bayes theorem problems, which, by the way, my students can solve without learning the theorem if they create a table like I'm going to show you. Let's take this example. Rosario works 5 days a week at a secure facility where employees cannot get in before 8:45 a.m. Each week, Rosario drives into work 1 day, rides the bus 2 days, and takes the subway 2 days. If she drives, there's a 15% chance she gets to work too early, whereas the chance is 5% if she rides the bus and 25% if she takes the subway. If Rosario gets to work too early, what is the probability she took the subway? Why is this a conditional probability problem? It is a probability problem because the question asks for the probability that she takes a subway. Let's use the word D for drive, B for bus, and S for subway, and E for being early, and maybe N for being not early. So the question is the probability she took the subway. But it's not just P of S. It's P of S knowing that Rosario gets to work too early. So it's P of S given that she got to work early. That makes it a conditional probability problem. Now, in fact, we also know that this is a Bayes theorem problem because we're given the probability that she gets to work early if she takes a subway. See how this part here and the question prompt are kind of switched around? One is 25% chance early if she takes a subway. The other is if she gets to early, what's the percent chance she took the subway? So yeah, it's sort of like switched back and forth, and that makes it a Bayes theorem problem. Let's look at this problem and see what's going on here. How many variables are there? You can see there are two variables. One variable is how Rosario got to work. That variable is categorical and has three possible values: driving, bus, or subway. And the second variable is basically what time she got to work. Did she get to work too early or not? When you have two variables, especially two categorical variables like this, it just calls out for a contingency table. It just calls out for a two-way crosstab. So let's define some notation first. Let's agree that D stands for driving, B for the bus, S for the subway, E for being early, and N for being not early. There are two variables, so like I said, let's make a two-way table. Along the columns, I'm going to put in the values of the first variable, how she got to work: driving, bus, subway. And then along the rows, I'm going to go either she got there early or not. At the end, I have the total, and at the bottom, I have the total. The key for setting up these tables is to put a grand total at the bottom right corner here, and then use the information from the problem to create the rest of the table. What kind of grand total should you put there? The answer is any number. Put any number where you think after calculating, you won't get too many decimals. I usually just have some big number like 10,000. Why is that permissible? How come I can do that? Let me give you a mathematical answer and a practical answer. The mathematical answer is because everything is based on percentages. Then if you grow the total, all the other cells would just get bigger proportionally. So by the time you take the probability, which is one number divided by another, things cancel out. So all the answers will be the same. All the probabilities will be the same. That's the mathematical answer. The more practical answer is that people are asking you a question about a person, Rosario. They say she goes to work 5 days a week, but they don't say how many months or years she's working. So we don't know how many total days Rosario goes to work. And yet they still expect an answer. That must mean that the answer does not depend on how many days Rosario goes to work in her entire career. If it doesn't matter, then that means the answer must be the same no matter what that number is. Might as well make up a number. And I'm going to make up a very large number, and you'll see why. I make a large number so that by the time I multiply it by a bunch of percentages, it's still a pretty decently large number, so I can divide easily without having to deal with a lot of decimals. There's nothing wrong with decimals, except that for some people, having to look at a long decimals just creates a psychological barrier, and can't do math when there's too many decimals around. All right, so the grand total is going to be 10,000. Now, what do we know about things? We know that 1 day a week out of 5, so that means 20% of the time, Rosario drives to work. 40% of the time, she takes a bus to work. And 40% of the time, she takes a subway to work. That means there's a total of 2,000 days where Rosario drives to work, 4,000 days taking the bus, and 4,000 days taking the subway out of the grand total of 10,000. Great. What else do we know? We know that when she drives, there's a 15% chance that she'll get to work too early. So that's 15% of the 2,000, making it 300 days. I'm going to do the same for the bus. And the subway. That makes it totally out of 10,000 days that Rosario works. She gets to work too early, 1,500 days by adding these three numbers together. All right, what about the rest of the cells? Well, these two numbers need to add up to 2,000. That means this empty cell here has to be 1,700. 300 plus 1,700 equals 2,000. I just subtract 300 from 2,000. Same thing here. These two cells ought to add up to 4,000. That makes this 3,800. $3,000. And now I add this horizontally. I get 8,500. And then I double check by adding straight down, and yes, it is equal to 10,000. So I'm good. And now the question asks for the probability that given that Rosario is early, what's the probability she took the subway? Well, here are all the times when she's early. That's total 1,500 times. Of those 1,500 times, she took the subway 1,000 of them. So the probability is 1,000 out of 1,500. And I simplify this, I get the answer of 2/3. The chance that Rosario took the subway, if he's early, is 2 out of 3. By the way, is the reason why I don't teach Bayes theorem in my intro class, because any Bayes theorem question that comes up can be solved by making a table. So why bother teaching the theorem, unless there's a point to it. And that point usually comes up in an intermediate or advanced class, not in an intro class. So I'll let the intermediate and advanced people deal with it. So in summary, this is what you want to do. You want to identify what the two variables are. Make sure there are just two variables. One will go along the column and the other one will go down the rows. In reading this problem, you see a lot of information. You see driving, you see bus, you see subway, you see early, and you see 8:45 a.m., which I hope you realize is just there for context, right? It's not there for you to calculate with. But you see all of those things, you need to be able to realize that that makes it two variables. There are two variables at play in this question. That allows you to make the two-way contingency table, where one way is the variable, how did Rosario get to work? It has three values, but it's just one variable. The other variable, I hope you also realize that if she's early to work some days, that means she's not early to work all the other days. That makes it a categorical variable with two outcomes, early and not early. The question never talked about being not early. You should be able to figure out that it's part of the situation. Once you have that, then you make your table and you put a large number for grand total. I usually go for either 1,000 or 10,000. Sometimes when the probabilities involve a fraction, like 1/3, then I'll make my grand total 30,000 so that it cancels out with the 1/3. And then use the information in the problem to fill in the table. Once you filled in the table, all the conditional probabilities become really easy to figure out. Hope that helps. Any questions? Ask in the comments. Like, share, and subscribe for more contents. Thanks for watching. Bye.